You always want to start with the smallest one because it is going to have the factors that are going to work for it. So in looking at this, I have 2 and I have 12. 2 is the smallest coefficient. 2 is a factor of 2. Is 2 a factor of 12? Meaning, can I take 12 divided by 2 and get a whole number? Yes. So I know I'm going to divide by 2 with both of these. Then you check out any variables that you have. Here I have an x. I don't have an x next to it. So I can't have a greatest common factor with an x. So 2 is what you bring out in front as that greatest common factor. Okay? And then you put the parentheses and you say, by dividing those terms by 2, 2 divided by 2 simplifies to 1, and x divided by 1 is just x. It's what you have left, okay? Minus the 12 divided by the 2 here gives me what, class? 6. So this is the correct factorization. It says determine if this is true or false. The expression factors to this, well, that is false. It's going to factor to 2 times x minus 6. And if you have to put a false in there, then you have to show what the correct factorization is. Okay? All right. Difference of squares. Difference. What subject or what operation does difference imply? Addition, subtraction, multiplication, or division? What operation does difference imply? Subtraction. So the difference of squares. Well, yeah, that's a square, and that's a square, okay? So when you have this kind of setup, a difference of 2 perfect squares, whatever is the first term gets factored as the first term in both binomials. So that's an A and this is an A. Whatever is the second term becomes the second term for both of those binomials. And the 2 signs that we have left are addition and subtraction. Now, it doesn't matter which one's first and which one is second. I always do the addition one first just because everybody likes addition better than subtraction. So, is this statement true? Is the difference of these 2 squares equal to a minus b times a plus b? Yes, that is true. It's kind of like saying, is 5 times 4, is that the same as, or 4 times 5, is that the same as 5 times 4? So yes, you can switch these around. Okay? Whew. All right, number 3, determine if this statement is true or false. The first step when it comes to factoring is to draw the box. Is that true or false? The very first step when it comes to factoring, do we draw the box? No. So that's a false. What is the very first step? That's right. The first step is to look, and I always like to put the eyeballs in there, look for a greatest common factor. You might not have one, but you do need to look for one, okay? And here's what I think as I'm going through this review. I think it's going to be best if I go through as many of these problems as I can, and I think I'm going to try to make you up a new review for you to work on maybe in class tomorrow. We'll see, because I want to make sure that you know how to do all these different types of factoring, okay? All right, So the next one, identify the choice that best completes this statement or answers the question. Factor the expression x squared minus 36 and be sure to show your work. Okay, we still have to show our work. So first step, what did we say I always need to look for first? GCF. So as I have x squared minus 36, what's my coefficient in front of that x squared? 1. So as I'm looking at the numbers and I look at the smallest one, the only factors of 1 are 1 and 1. And a greatest common factor of 1 is not helpful. So there is no greatest common factor. Okay? 2, is this a difference of 2 squares? Well, difference, there's definitely a subtraction sign. What I need to determine, are these both perfect squares? Okay, well, let's take a look. X squared is just x squared, x to the second power. Minus, is there something that I can change this 36 to that number times itself gives me 36? 6. So we're going to rewrite that as 6 squared. I always want you to try to rewrite it as something squared. Now it is a difference of 2 perfect squares. All right, I know I'm going to have multiplying by 2 binomials. Okay. My first term is just going to be that x by itself for both binomials, for both of them. Okay. My second is going to be the second term that has been squared. And the signs in between are just going to be plus and minus. So as I look at these answers here, which of those match up with the answers below? Any of them? Letter D. Oh, Miss Thede, it's in a different order. Is that okay? Yes, that is okay. Like again, this is 5 times 4 is equal to 4 times 5. So number 4 is letter D. Okay. Are we feeling a little bit better about the difference of 2 squares? All right, let's go to number 5. Circle all factors. Circle all factors of 4x squared minus 36. All right, so I'm going to write this over here. And it says show your work. We do need to show our work here. Just because it's multiple choice doesn't mean we just like put some answers down. All right, what is the first step when it comes to factoring? Find the greatest common factor, if there is one. Greatest common factor. So I look at 4 and 36. You start with your numbers. So 4 is a factor of 4. Is 4 a factor of 36? Yes. So we need to factor out a 4. Next, I have x here, but I don't have any x in the second term. So can I factor it out 4x? No. But I can factor out that 4, which means I pull that out in front. Times, what do I have left? 4 divided by 4 is 1. And I have the x squared left minus 36 divided by 4 is how much? 36 divided by 4? 9? 9. Yeah, pick up, there's a review worksheet right there in the corner. All right, so this is my greatest common factor here. But then I've got this x squared minus 9. I don't have another greatest common factor, but then I look for a difference, that's subtraction, of 2 squares. well, hey, I think we just had this one not too long ago, so I got to put the 4 out front still. We just keep dragging that 4 along, okay? And then I will rewrite this as x squared minus what number squared gives me that 9? Luis, do you know? What times what gives me 9? That's the same number. Yes, very good. 3. So I changed this so it's 3 times 3. Now I definitely have a difference of 2 squares because it's x squared and 3 squared. So that 4 just keeps coming on down. And then I'm going to write this as my first term, which is just the singular version, x. And that goes in the first spot of both binomials. All right. And the second term is going to be the 3. I put a plus sign on the first and a minus sign on the second. And that is the factorization of that initial binomial. Now, it says to circle all the factors. Is 4 a factor? Yes, it was from the beginning. X plus 3, that's letter F. And x minus 3 is letter E. So I need to write A, E, and F all over here for my answers. All 3 are factors. Questions about that? All right. I'm just looking. All right, let's do number 6. Says, find the greatest common factor for 4m to the third n to the second and 24m n to the third. Be sure to show your work. All right. Greatest common factor. First of all, I have a 4. I need to list all the factors of 4. So I've got 1 and 4. And what else? What'd you say? What are the other factors of 4? 1 and 4 and what? 2 and 2. Now, it says m to the third. How many m's is that multiplied out? 3, right? M times m times m, right? Write it down. M times n. And n squared would be 2 n's multiplied. All right? So I have all the possible factors there for 4m to the third n squared. All right, let's take a look at 24m n to the third. Factors of 24. List them. Yorn, don't look at the phone. List them as 1 and 24. 2 and 2 times what gives me 24? 2 times 12. How about 3? 3 and 8. How about 4? 4 and 6. So if you don't know your factors really well, you got to be checking with your calculator saying 24 divided by 3. Does that work out to be a whole number? 24 divided by 4, is that a whole number? How about 5? We're on number 6. Are you on number 6, Kamari? Okay. 5 does not. And then it goes back up to 6, so you know you've got them all. All right? Then it says m. How many m's is that? 1. 1m here for 24m n to the third. And my n's are n to the third power, which means n times n times n. So to find the greatest common factor, again, start over here with your smallest coefficient. 4 is 4. 4 is a factor of here. 4 is also a factor of here. So that's got to be the largest because it's the greatest common one. How many m's can I factor out from them both equally? How many m's can I take away? 1. Yeah, this only has 1, so I can only take 1 from that. And how many n's can I take away from both? 2. So that means my greatest common factor is everything that I circled. 4, m to the first, or just m, and n to the second. That's finding the greatest common factor. Okay? All right, listen to me very carefully. I want you to try to finish up this review. Okay? Finish up this review and try to work on any of your missing homework assignments. Guys, please stay in your seats. Please stay. Okay, we don't have to jump out of here. And any missing assignments 1 through 4. All right. Do most of you feel like you understand difference of 2 squares a little better? All right, we'll see you tomorrow. Try to finish that review.